Morning students, in the last session we completed the course outcomes and syllabus of the engineering mathematics 1. Now in this class we are going to the applications whatever we discussed in the last class. Those applications we are discussing here again. The main applications of differential equations of first order and first degree are biology and economics. Differential equations are used to model the behavior of the complex systems. So these differential equations are using to modeling the biology and economics operations. Coming to the next one, and these partial differential equations are also useful in heat transfer, elasticity and quantum mechanics. Water flow models are governed by the partial differential equations. Already we discussed about the ordinary and partial differential equations, and these models related to the ordinary differential equations, and these models are related to the partial differential equations. Some more applications are these differential equations are used to form a physical models which are related like Newton's law of cooling. So those applications are also here we mentioned. The Newton's law of cooling, law of natural growth or decay, mixture of two salt solutions and electrical circuits. In these also we are framing the physical models of the physical models of these are all by using differential equations. Coming to the next one. Here, what is the function? So here first we have to learn about the function. What is this function? Y is equal to f of x is a function. So y is a function of x. Y is a function of x. Then this function y is equal to f of x is denoted by in this format. Here x, where is x? This x is called an independent variable and y is called a dependent variable. What is an independent variable? That variable we are taking as like our choice. So any value we are applying to that function, then based on that x, that y value will be changes. In this way, this y is called dependent variable and this x is called an independent variable. Now definition of definition. So what is the differential equation? An equation involving independent variable, dependent variable and independent variable, dependent variable and their derivatives. So dependent variable derivative with respect to the independent variable, they are the derivatives. If these are all involved in the differential equation, then that equation is said to be a differential equation. Now, what is an order of the differential equation? Order. What is the order? The highest derivative. The highest derivative occurs in the differential equation is called the order of the differential equation. Similarly, here degree. What is the degree? Power of the highest derivative occurs in differential equation is called degree of the differential equation. So here we learned three definitions. Already you know these three definitions. What are those three definitions? Differential equation, order of the differential equation, degree of the differential equation. So what is differential equation? Any equation involving independent variables as well as dependent variables and their derivatives, then that equation is said to be a differential equation. What is an order? Order means the highest derivative occurs in the differential equation. Highest derivative occurs in the differential equation is called the order of the differential equation. Coming to the degree. Degree means whatever highest order derivative existing in this differential equation, the power of the differential equation is called degree of the differential equation. For example, dy by dx plus y is equal to 0. So here, if you are observing here, you are getting only one derivative, first order derivative. So this is called order of the differential equation. Coming to this one, what is the power of this one? 1. This 1 is called degree of the differential equation. Similarly, another example, d square y by dx square whole square plus 2 into dy by dx plus y is equal x square. So here, if you are observing that equation, here this equation involved the second order derivative. So order of the differential equation is equal to 2 and degree of the differential equation, the power of this second order derivative is 2. So degree of the differential equation is also 2. So this is called the order and degree of the differential equation. Next one. Next one, differential equations. So differential equations are differential equations. So here already we discussed about the differential equation, order and degree. Those three you all know as a basic concepts. Here I am saying some more basic concepts related to the differential equation. Those are also you know. So I am discussing about those are all. So here see this one. Differential equations are classified as two types. One is ordinary differential equation. Another one is partial differential equation. What is an ordinary differential equation? An equation involving one independent variable. An equation involving one independent variable, one dependent variable, one dependent variable and one dependent variable and derivatives with respect to independent variable is called an ordinary differential equation. That means any differential equation is said to be an ordinary differential equation that should having one independent variable, one dependent variable, and the derivative of dependent variable with respect to independent variables are existing in the differential equation. Then that equation is said to be ordinary differential equation. Coming to the partial differential equation. So partial differential equation means an equation involving one independent variable, one dependent variable, two or more independent variables, one dependent variables, two or more independent variables, and dependent variable derivatives with respect to independent variables is called partial differential equation. So what is the difference between ordinary and partial differential equation? Ordinary differential equation means an equation involving only one independent variable, then that equation is said to be ordinary differential equation. If that equation involves two or more independent variables, then that equation is said to be partial differential equation. So dependent variables and independent variables. Dependent variable is 1 and independent variable is 1. Then this equation is said to be ordinary differential equation. If dependent variable is 1, independent variables are 2 or more, then that equation is said to be partial differential equation. So differential equations are classified as two types. One is ordinary differential equation, another one is partial differential equation. In this session, we are in this first unit, we are learning about only how to solve the ordinary differential equation. For example, what is an ordinary differential equation? Example related to the ordinary differential equation is dy by dx plus xy is equal to x square. So here see this, y one dependent variable, x we have only one independent variable. So this is dependent variable and this is independent variable. Now coming to the partial differential equation, dou square f by dou x square plus dou square f by dou x dou y is equal to 0. So such type of equation. Here observe this, f is dependent variable, that is only one variable, x is x and y, two are independent variable. So this is called the partial differential equation. So this is an example for ordinary differential equation, and this is an example for partial differential equation. Now different types of differential equations. These are all ordinary differential equations. In this our first chapter, we are learning only how to solve the ordinary differential equations. So in that, variable separable equations, homogeneous, non-homogeneous, exact, non-exact, linear, Bernoulli differential equations. So here 7 types of differential equations we are learning. They are variable separable equations, homogeneous equations, non-homogeneous equations, exact equations, non-exact equations, linear equations, and Bernoulli's equations. So coming to here, variable separable, homogeneous and non-homogeneous. Variable separable, homogeneous, non-homogeneous. These 3 concepts are called prerequisites. Because of that, you all know about these 3 methods in your previous standard levels. Now we are in this unit, we are learning about exact equations, non-exact equations, linear equations, Bernoulli equations. And our public papers, our university papers consisting only these 4 method problems. So these 3 methods are only prerequisites to you. Next, coming to this one. Here now just a basic level of problems I am discussing about the prerequisites, variable separable equations. So in this variable separable equations, the first order differential equation, any equation is of the form dy by dx is equal to f of x comma y is called variable separable equation if that f of x comma y should written in the form of g of x into h of y, then only we are saying that this function is said to be then only we are saying that this equation is said to be variable separable equation. After coming to that equation in the form of dy by dx is equal to g of x into h of y, then we are bringing all one variables into one side, all another variables into another side. Here see this is a function of y. Here the dy is in numerator, so bring this h of y into this side. This multiplication comes to this side is division. 1 by h of y into dy is equal g of x. This dx comes to this side, g of x into dx. So now integrate this one on both sides, we will get the general solution of this equation. So in this variable separable equations, what we are doing, we are writing the given equation in the form of dy by dx is equal to function of x comma y. After that, we are splitting function of x comma y as a product of 2 functions. In those 2 functions, one is in terms of x function and the one is in terms of y function. If you are getting any equation in this format, then we are solving those equations by using variable separable method. Now here a small example related to the variable separable method. So what is the equation? Find the solution of the equation dy by dx is equal to y. So here say this dy by dx is equal to y. Y can be written as y into 1. Y is a function of y. 1 is function of x. How you are saying that 1 is function of x? Because of that 1 can be written as x power 0. In that's why I taken that one as a function of x. Now say this dy by dx is equal function of y into function of x. So what we are doing, this function of y into the left hand side. What is the function of y? Y. So y brings to the left hand side, x goes to the right hand side. So 1 by y dy is equal dx. Now integrate on both sides. 1 by y integration. What is the formula of integral 1 by y? Integral 1 by y is equal log y. Let's see. So here 1 by y integration is log y. Here this is integrand 1. What is the integration of 1 with respect to x? X plus, here we are getting one constant, here we are getting another constant, total one constant as, see here I written where c is said to be an arbitrary constant. So like this we are evaluating the solution of the variable separable method. Now coming to the next one, homogeneous equation. So what is a homogeneous equation? A function f is said to be homogeneous equation if that function can be written as f of t tx comma ty So this one is f of tx comma ty is equal t power n into f of x comma y. Then that function is said to be, this function, whatever function existing f of x comma y, this function is said to be nth degree homogeneous equation. So this is one of the definition. Coming to another definition, a first order differential equation. Any first order differential equation can be written in the form of mdx plus ndy is equal to 0 is said to be homogeneous equation if the terms of the functions m and n are homogeneous functions of x and y with the same degree. That means if suppose m consisting 2 or 3 terms, so the degree of each and every term is same, and similarly the degree of each and every term in n is also same, then only we are saying that the function is a homogeneous function. Based on these functions, we are using any one of the definition related to the homogeneous equations. These are also prerequisites for you because of that variable separable method equation, variable separable equation, homogeneous equations, non-homogeneous equations. These are all variable separable equations. So working rule of this one also you know. So what is this working rule? Put the given equation in the form of, first we have to write the given equation in the form of mdx plus ndy is equal to 0. After that, check whether the given equation is homogeneous function or not. That means homogeneous means that one is having same degree terms or not. After that, we are substituting y is equal to vx and dy by dx as v plus x into dy by dx. So we are substituting these two values in the given equation. So how we are substituting those values? First you have to convert that equation into the form of dy by dx is equal to term. So after writing of that, you have to write y is equal to vx, dy by dx is equal v plus x into dv by dx. So substitute these are all values in this equation. Then after that use variable separable method, you will get the solution of the differential equation. At the end you have to replace v as y by x, then only you are getting the general solution. Why? Because of that here we are substituting in the starting y is equal vx. Our equation consisting only x and y terms, but our result is having the term v, and that's why from this v value is y by x, and that's why I substituted v as y by x. So this method is also you know. So variable separable method, homogeneous equation. So what is the homogeneous equation? For example, dy by dx is equal x square plus y square by xy. So here how many terms are here? This is one of the term, this is another term, this is another term. Because of that it is a product, it is the sum. So what is the degree of x? 2. Degree of y? 2. Degree of x? 1. Degree of y? 1. Together is the one term. So 1 plus 1, 2. So each and every term in that equation having the same degree. So it is said to be a homogeneous differential equation. Example. So whatever I said the example, dy by dx is equal to x square plus y square by xy. For your understanding purpose, here I am solving this equation. So what I said, it is homogeneous or not? Say this, the degree of this one is 2, degree of this one is 2, degree of this one is 2. So this equation is homogeneous differential equation. After coming to the homogeneous differential equation, what is our step? Put y is equal vx and dy by dx is equal v plus x into dv by dx. So substitute those are all in this equation. So dy by dx is v plus, let it be 1. So from 1 implies v plus x into dv by dx is equal x square plus y. What is the value of y? Vx whole square. Vx means v square x square by x into y value is Vx. So numerator having the term as common as x square. Take out that one as common. Then this one changes as v plus x into dv by dx is equal. Take out common x square. X square into 1 plus v square by x square into v. X square getting cancelled. So that implies bring this v into the right hand side. Then this one x into dv by dx is equal 1 plus v square by v plus v goes to that side minus v. Take LCM. What is LCM? V. So 1 plus v square. Here 1 into v times cancel. V into v square. V square getting cancelled. This value is 1 by v. So what we got here implies x into dv by dx is equal 1 by v. Here numerator having v. So say observe this. This one is in the variable separable form. So bring this v into the left hand side. This x into dx into the right hand side. Then this one is v into dv is equal. This x comes to this side 1 by x into dx. So we after that make it use. So observe this. Variables are separated. All v's are one side. All x's are another side. So make integration on both sides. Integral v dv is equal integral 1 by x dx. What is the integration of v? V square by 2. 1 by x integration is log x plus c. That implies v. What is the value of v? Y is equal to vx. From this, what is the value of v? V is equal y by x. So substitute v value as y by x. So this one changes as y square by 2x square is equal log x plus c. So like this we are solving the differential equations of homogeneous. So already you know this method, and next method is non-homogeneous equation. That one also I think so you know about that. So in that's why I am skipping that one. So next I am going to the exact equation. So this exact differential equation. This is the main concept of our BTech first year. So already how many members have? I think so. Some of the members having an idea about an exact differential equation, because of that who prepared for MSET examination and JEE examinations, they are all aware of the exact differential equation. So here I am saying this definition. So what is an exact differential equation? So exact differential equation means first ordinary differential. Here I am saying about only ordinary differential equations. So ordinary differential equations of first order and first degree. So first, so we have to convert the given equation into the form of m dx plus n dy is equal to 0. So here m is a function of x comma y, and n is also a function of x comma y. So m dx plus n dy is equal to 0. This equation is said to be an exact differential equation if there exists a function f. If there exists a function f such that the partial derivative of this f, with respect to x should be equal to m, and the partial derivative of f with respect to y equal to m. That means an imagination. So m and n terms I want. So here m means the partial derivative of m with respect to x is f with respect to x should be equal to m. Such a type of function you have to evaluate. So this one becomes some difficult to evaluate that such type of function f. And that's why here there is a necessary and sufficient condition existed for this exact differential equation. That one also I given as a definition. So see this. What is an exact? See this. A first order differential equation m dx plus n dy is equal to 0 is called an exact differential equation if the partial derivative of m with respect to y is equal the partial derivative of n with respect to x. If any differential equation satisfying this condition, then we are saying that that function is an exact differential equation. Actually, the definition of the exact differential equation is this one, but it is not. Here we have to guess that function f How we are guessing that function? The partial derivative of f with respect to x should be equal to m. The partial derivative of f with respect to y should be equal to n. Such type of function we have to guess. So it is not possible every time. In that way, here we are using the necessary and sufficient condition related to that. So what is the necessary and sufficient condition? Dou m by dou y is equal to n by dou x. So in each and every case, this given equation is an exact or not. How we are checking? By using this condition only we are checking. So it is very important in our chapter. So here dou, so ordinary derivatives and partial derivatives. Dou means these are the partial derivatives. Now working rule. How to solve an exact differential equation. So here mainly the equation consisting 3 steps. These 3 steps are required to solve any exact differential equation. So say this. First you have to convert the given equation into the form of m dx plus n dy is equal to 0. After converting the equation into that format, we are checking that the partial derivative of m with respect to y and the partial derivative of n with respect to x. So we are calculating these two partial derivatives. So after calculating those two partial derivatives, if those two are equal or not, we are checking. If those two are equal, then that equation is said to be an exact differential equation. If those two are not equal, then that equation is said to be a non-exact differential equation. First we are learning about the exact differential equation solution. So what is the so if these two are equal, then the equation is said to be an exact differential equation. Every differential equation having a general solution. So here general solution we are obtaining by using the formula integral m dx y constant plus integral n dy terms not containing x is equal to c. Here you have to observe this. So in this integral, whenever you're doing this integral, in that integral you have to treat y always as a constant term. So how you are writing 2 outside from this integral like this, you have to write y also from this integral. And coming to this one, integral n dy is equal to c terms not containing x. The meaning of that one is how many terms are existing in n. We are checking that in that n, which terms not having x, those terms only we are making the integration. So these two are very important in finding the general solution of the exact differential equation. So you have to remember this one. What is that? Integral m dx. In this integral y should be constant plus integral n dy, and in this integral we are writing only the terms which are not containing x value. So those terms only we are writing here. After writing this one, we are evaluating the general solution of the given differential equation. So here an example related to this one, check it. So say this. Solve the differential equation 2xy dx plus x square plus 3y square dy is equal to 0. So coming to this one, what is the given equation? 2xy dx plus x square plus 3y square dy is equal to 0. So you should compare that equation with m dx plus n dy is equal to 0. So here what is the m? So dx coefficient. So what is the dx coefficient? 2xy. So m value 2xy. Coming to the n, what is the value of n? Dy. Dy coefficient. So what is the coefficient of dy? X square plus 3y square. X square plus 3y square. Now partial derivative of m with respect to y. What is the meaning of partial derivative? With respect to one variable you are doing, that means remaining all variables you treat it as a constant terms. So here see this one. Here I am making this partial derivative of m with respect to y. With respect to y means treating x as a constant. So here see this one. Here we have only one term. So treat x as constant. So 2 constant, x constant. Write this 2x outside. Y derivative with respect to y. What is the derivative of y with respect to y? 1. So 2x into 1 value is 2x. Similarly, dou n by dou x. So with respect to x means treating y as a constant. Here n consisting of 2 terms.
In those two terms, this term does not having a x value, so the term is a constant term. Constant derivative with respect to any variable is 0. So the derivative of that one is 0 plus x square. What is the derivative of x square with respect to x? 2x. So dou m by dou y value 2x and dou n by dou x value is 2x. That means dou m by dou y is equal dou n by dou x. That means given equation is exact. Given equation is exact. So first step completed. So what is the first step? We are comparing the given equation with mdx plus ndy is equal to 0. After that we are evaluating the partial derivative of m with respect to y, the partial derivative of n with respect to x. If those two are equal, then that equation is said to be an exact equation. So up to that step completed. After that what we are doing? We are evaluating the general solution of the differential equation. So what is the general solution formula? Integral m dx y constant plus integral n dy terms not containing x. So here m. So m consisting. So see this previous one. So see this one. What is m? 2xy. N value x square plus 3y square. We are writing that. M value 2xy. N value x square plus 3y square. Now say this. General solution formula is integral m dx y constant plus integral n dy terms not containing x is equal to c. So here m. What is the value of m? 2xy. In that there is a variable y. So write that y outside, y into integral 2x dx. Because of that in this integral y treated as a constant term. Coming to here n. What is the meaning of here n? Which terms not containing x? See this here, this one having two terms. In those two terms one term having x. So remove this one. What is remaining? 3y square. So you have to make the integration of 3y square. So y into 2 is also constant. Right, this 2 is also outside. What is the x integration? X square by 2 plus 3 into y square integration is y cube by 3 is equal to c. 3 getting cancelled, 2 getting cancelled. So what I will get? X square y plus y cube is equal to c. So this is the general solution of the exact differential equation. Like this we are evaluating the general solutions of the exact differential equation. Now in this class I will say one more example also related to the exact differential equation. Say this, with this example we will complete the general, so we will complete this session. See this. Now so this is the last this is the example related to the exact differential equation. With this problem I will conclude the this session. Now say this. What is the given equation? So what is the given equation? E power y dx plus 2y plus x into e power y dy is equal to 0. So this is the given equation. So in first step what we have to do? We have to compare this equation with m dx plus n dy is equal 0. So dx coefficient is m. What is the value of m? M value is e power y. N. What is the value of n? N is equal 2y plus x into e power y. After that, what we are doing? Evaluating the partial derivative of m with respect to y. So dou m by dou y. What is the value of dou m by dou y with respect to y? There is only one term, e power y. What is the derivative of e power y? E power y. Next, with respect to x, dou n by dou x. So with respect to x, here there is no x. So the derivative of this term is 0. And here there is x. So other than x, e power y. Here partial derivative. Partial derivative means we are doing only one variable. Other variable we are treating as a constant. So e power y is the coefficient. X derivative with respect to x is 1. So e power y into 1 is e power y. So dou m by dou y e power y. Dou n by dou x e power y. So dou m by dou y is equal dou n by dou x. That means given equation is exact. So exact condition completed. Now we are evaluating general solution. What is the general solution? So general solution is what? Formula integral m dx, here treat as y as constant, plus integral n dy, and in this integral terms not containing x is equal 6. So integral m, what is the value of m? This one having only one term, write that one, e power y dx. Remember this, y constant, plus terms not containing x, n having two terms. This one does not have x, this term having x. So remove this term, so only 2y. So n value is 2y, dy is equal to 6. In this integral, y is constant, so write that y outside. Remaining is what? 1. 1 integration with respect to x, x, plus 2 into y integration with respect to y square by 2 is equal to c. 2 getting cancelled. So this one is what? X into e power y plus y square is equal to c. This is called the general solution of the given differential equation. So with this problem, our topics are completed. So here, whatever we discussed in this session, so here I am mentioning this. So in this, I said about the different methods, different differential equations, different differential equations, and types of differential equation, types of ordinary differential equations. In the types, I discussed about variable separable equations, homogeneous and non-homogeneous equations, and at the end I completed about the exact differential equation. So in this exact differential equation, what we discussed? That equation is an exact, then only we are evaluating the general solution. In the next class, I will discuss about the non-exact. What is the meaning of non-exact? Whenever the condition fails of exact, that means dou m by dou y not equal to dou n by dou x, then we are saying that that equation is a non-exact differential equation. So in the next class, I will discuss about the non-exact differential equations. Thank you.